Good evening. Hello, everyone. I hope you are doing well. Today, we will discuss application of software IB or interactive petrophysics to the purpose of log analysis and petrophysical interpretation. We will try to uh, we will try to start the task of estimation of V-share by using the IB software. Uh, let's start by opening the software. So my first task is to import my data. I have saved my data on desktop as last file. So I will select to browse for IB database, and then I will search for my file including the data. Here's the file including the data, and then OK, and then OK, and then I will now from input output I will select to load data. We can load data to IB in different formats, including the ASCII format, the LAS format, and LIS format, GLIS format. So we can use different formats. I will select to load data as LAS format since the data saved on my file is the LAS format. So I will select LAS format. This is the data, demo data. I will open it. As you will see, we have the different logs included in the data and the different tracks. We have depth, the bit size, the caliber, and the compensated neutron log, the delta T for sonic log, the gamma ray, and we have a range of resistivity logs with different depths of investigation from M2R1, M2R2, M2R3, M2R6, M2R9, M2RX, and RMSL. These are resistivity logs with different depths of investigation. We have also the BEF log as the SOGI indicator, the SB spontaneous potential, the Z correction is a correction for bulk density log, ZDNC is the bulk density log itself. So I will click the symbol right in front of each data I want to load. So for example, I will click right here to the depth track, and all of the other logs are already clicked right. And then I will load data. Now I would like to display this data on our conventional logs. So we have some predefined format for displaying the log data. So we can make some quick plots of the data by using these predefined format. We just click on this icon here, and then in the file menu, I will select program default plots. You will see a pop menu including 3 tracks blank, 4 tracks blank, composite CBI, density neutron, shading, and density neutron. And the most common display is the triple combo. I will click on triple combo. And as you will see, we have displayed the data here as triple combo. The triple combo is consisting of three major tracks in addition to the depth track. The first track here includes the conventional logs used for the purpose of estimating the clay volume or shell volume. For example, the gamma ray log and the SP log. These are primary conventional logs for estimating the shell, in addition to the caliber log for indicating the borehole diameter. So this is the first track. We can call it as or refer to it as basically as lithology track. The second track is displayed in logarithmic scale. It is including the resistivity logs. Since the resistivity logs will usually cover a wide scale from around 0.2 ohm meter to around 2000 ohm meter. So we cannot use normal log for displaying this large scale. So we use logarithmic scale. This is the second track will be displayed as logarithmic scale. The third track will include the porosity logs, for example, the compensated neutron here, and the correction for density. And as you see that some logs are not already displayed on this plot, we can introduce these logs here to view all of the logs with new data. You will choose from view the database browser, and so this is the view file. I will click on it. You will see the default, and so you will click on default. You will see the different logs displayed or including on your database. To display any log, you have only to just click on this log and drag it to the suitable track. For example, I want to display bit size on the first track, so I will drag it on the first track. You will see the bit size displayed here. Also, the caliber is already displayed. We have the caliber already displayed here. While also the depth is displayed, gamma ray, and regarding the density, it is not displayed within the porosity track, so I will drag the density here. But since this scale representing 0 to 0, this means that the software didn't yet identify the density, or that the density, the scale of density have to be adjusted. So I will click on the header of this track and then choose the scale of density. Usually scale of density for the case of limestone calibrated logs is ranging from about 1.95 to 2.95. And we can change also the colors. For example, neutron is displayed in green. I will choose to display it in blue. And usually we display it as dashed Newton is displayed usually as dash, while for density, I will display it on red as solid line. So this is the density correction. For density correction, I will display it on black. While for density, I will display it as red. And then click apply. So we have displayed the density here, and also we have the Newton displayed as blue, and the delta rho B of the density correction is displayed as black here. So this is the we have already displayed these positive tracks. Also, we can introduce a new track by right click and choose a new track, and I can drag it here by clicking on the header and then by right click on the header and then drag it here. So already we didn't display yet delta T. So I will drag delta T sonic here to this new track. And also BEF is not displayed, so I will drag BEF here. We can check on the scale by click on the header of this track. Already the scale from 40 to 140 microsecond per feet for delta T, and for BEF it is from 0 to 20. Okay. We can change also regarding the colors if you would like to change the colors of these tracks, and then for example to make delta T, for example, as blue, and then apply, and then okay. So already we have displayed the sonic and BEF, and we would like to know what is the purpose or what is the usefulness of the triple comb predefined format. As you will see here, this is the traditional sequence flowchart of traditional interpretation. Our basic input is data for estimating V shell and data for estimating porosity, data for estimating resistivity or reading the resistivity. So V shell, like for we can estimate V shell primarily from gamma ray and SP. So all of these logs are displayed in track number 1 in the triple comb. While for the porosity data, including neutron density, we can display it in the triple comb in track number 3. While for resistivity data, it is already displayed in triple comb in track number 2. So the 3 tracks of triple comb will correspond to the basic types of data, the three basic types of data we need in the traditional interpretation to get the fluid saturation. Basically, we should have resistivity data, porosity data, and V-shape data. And then the sequence goes by correcting the porosity values for the effect of shell by using the formula to estimate phi effective from phi Newton density or phi total. And also at the same time we can estimate estimate the resistivity of deep resistivity and the flush zone resistivity RT and RXO. In addition to the fluid resistivities RW, RMF. And then finally we get these data into a saturation equation model. Basically, any saturation equation model is just describing the water saturation as a function of formation factor, which is already the formation factor is already a function of porosity, as you see here, of effective porosity. And the second parameter is the resistivity, whether it is resistivity RT, deep resistivity, or large zone resistivity, and the fluid resistivity RW and or RMF, and some saturation models of some saturation equations will introduce also the effects of V shale and the effects of R shale into the equation to estimate saturation equation. To correct for all of the effects on of V shale on the porosity and resistivity measured by the logs. So, for example, for the unembedded zone, we have the saturation of water in unembedded zone is SW, will be a function of formation factor, deep resistivity, formation water resistivity, and some models or some equations will introduce factors for V shale and R shale to make some corrections for the effects of shale. While for flush zone, SXO will be a function of formation factor RXO, RMF, and some models will introduce V shale and R shale. So basically, a triple comp will be corresponding to using the three major types of data to be put into a sequence to estimate the water saturation. And from estimating water saturation, you can also estimate the hydrocarbon saturation of each zone. From the common relation, it is 100% minus or 1 minus water saturation of this zone. So this is the basic purpose of the three tracks involved in the triple comp. And we return now to our display. From this display, you can see basically this is a demo of sand shale sequences. And you can also display the different resistivity logs. Some service companies use just 3 resistivity logs to cover the invasion profile. For example, a resistivity log measuring in a flash zone, and a resistivity log for the transition zone, and a resistivity log for the unembedded zone. Just 3 tracks. And some other service companies can use 6 tracks to make some detailed invasion profile, and others use also 9 curves to make some more detailed invasion profile. Let's only use 3 tracks, 1 for flash zone, 1 for medium or transition zone, and the third for the unembedded zone. Basically, M2RX in this data will be corresponding to the deep resistivity. So I have to introduce M2RX into the resistivity track here. This is M2RX. M2R3 representing the medium or transition zone. M2R3. And then RMSL representing the flash zone resistivity or microspherical resistivity. Just I want now to make some more visible presentation of these logs. I will click on the header of this track to adjust just the display parameters. We will use just three resistivity logs. M2 we will just use M2RX here and M2R3 and RMSR. So I will delete the right from here, and then I will define the limits of scale. Limits of scale of resistivity from 0.2 ohm meter to 2000 ohm meter. This is the conventional limits of the resistivity scale. 0.2 to 2000. From 0.2 to 2000. And also we can adjust the colors. Let's make M2RX, for example, as blue. And make it dashed. Style, we can make it dashed. For M2R3, we can use it, the medium, we can use it in another color, a different color. Let's make it, for example, green or dark green, and we can display it as dot dashed. For the RMSL or flash resistivity, we can make it red. The color will be red. Red, and make it as solid. And then click apply. Okay. And okay. So you have the three resistivity caps, M2RX, M2RC, and RMSL. Also, we can illustrate the invasion profile by making shading. So I will click on the header, and from shading, I will select from RMSL. You can choose RMSL to M2R3 to be visible, and the shading type, let's choose a color to represent the shading between the microspherical resistivity or flash zone resistivity and the transition zone resistivity. Let's make the color of shading, for example, to be yellow, while from M2R3 to M2RX, let's make the color of shading to be, for example, orange. And then apply, and then okay. So as as you can see, we have displayed the injection profile here by shading of the separation between the resistivity blocks. Also, we can apply shading on the neutron density on the track of velocity or neutron density track by clicking on the header of this track and then select on shading from the density, the DNC, to the neutron CNCF. Since it is essential sequence, so from density to neutron will be displayed, or we can display it as sandstone. Sandstone. Can use the shading of sandstone and then apply. So we the software didn't yet identify the density log here. So we introduce only ZDNC as being density log. So I will click yes, and then we have already displayed the sandstone here. Apply. Yes. Okay. So we have displayed the sandstone here. Whenever ZDNC is to the left of the neutron, we have the sandstone shading here. So this is about displaying the shading. So as we have discussed in this first step, we have imported our data and we have organized our data to be displayed in triple-com format. And now we can also use the same format for any last file, another last file for another well. And so to apply the same format of we have chosen here to all wells, we just select from file, we select save plot format. From file here, I will choose save plot format. So I will save one version on the desktop. And for example, I will call it triple.com. And save. Now, as you will see here on the browser, you can see that there is on the log blocks, you can see that there is some default log. Now, regarding the scale, you can zoom on any part of the log by changing the scale on the scale box. You have here this well is displayed as a full scale, but we can change it, for example, to scale 100 or to another scale 200. You can change the scale as you would like. and this can be done by selecting the option you would like from the scale box. Also on the rightmost hand track, we will find a track which is presenting overview of the loaded data here. And by clicking on this track, we can move to any part of well, ranging from the top of well to the bottom of this well. And by clicking on any part, you can see the parameters at the bottom of the window. Now let's suppose that we have identified the formation tops, for example, for a certain composite or from some formation tops that have been collected in Excel sheet. We can introduce these tops here. From well, I will select manage zones or tops, manage zones or tops, and then I will select new top. Let's call these tops as formation tops. And we can also import it from Excel file, and then we can either import it as Excel sheet or import it manually by hand. So, for example, I will import it manually. For example, zone one. Let's make it, for example, starting from for example, zone one starting from the start or the top of the well. Here is the top of the well starting from 5,200. So let's make it 5,200. And then, for example, I will move into, let's make this formation top into 5,300. 5,300. So this is the first top. For the second zone, zone 2, starting from 5,300, and then from 5,300 we can move into 5,000 380. 5,380. 5,380. And the last one, zone 3, from 5,380 to the end of this or to from 5,380 to the end of this here. 500, 5,440. 5,440. Then we click OK. So to view or display these zones, we just left click on the header of the depth track, and we will fill in this window. In the index, I will select zone, and then in the depth, I will select the formation tops, and then I will make it visible, and then apply, and then OK. You can see here we have displayed the formation tops imported from Excel sheet or imported from another source of data. So till now we have displayed our log, and also we have rearranged our. Now we have imported our data, and we have displayed our data in a conventional table.com format, and the data are now suitable to apply the sequence of interpretation. As we have discussed, that we will start our interpretation conventionally by the estimation of the shade. As we have discussed here, the first step will be V-shade estimation. So we will start by V-shade estimation. Now, as you will see, for the sequence of interpretation stages, you can see the clay volume calculation, and we have different options for the clay volume calculations, including either introducing the parameters or the cutoff for clay volume estimation manually or from table, or to make the change of clay volume cutoff parameters by graphically. Also, the second stage. This is the first step of interpretation. Second step will be the porosity and water stage, the estimation of porosity and water station stage. Also, you have two options: either to make the adjustment graphically, or by using a table of porosity and water saturation parameters. And finally, we get into the stage of cutoff and summation. Also, you have two options, either graphically or as a table of parameters, or cutoff and summation parameters. So these represent the three basic stages: clay volume stage, porosity and water saturation stage, cutoff and summation stage. Let's start today by the clay volume stage. We have two options for clay volume: either graphically or by adjusting the cutoff parameters for clean, or the clean and shade cutoff by a table of parameters. We just click on the clay volume, B shale. Then we have this window for clay volume analysis. We have two basic options for the clay volume analysis here. As you will see, we can use a single indicator, single clay indicator, or we can use double clay indicator. Single clay indicators that are commonly used includes gamma ray and SP. So I will, we can select gamma ray as a single clay indicator. This is regarding the single clay indicator. Sometimes we can use also resistivity in addition to gamma ray as some single clay indicators. But till now, I will select the gamma ray. For double clay indicators, we have the density neutron and the density sonic, the sonic neutron. We commonly use the density neutron as double clay indicator. As double clay indicator. And the output from double clay indicator will be the clay volume from neutron density, while the output from using gamma ray as single indicator will be clay volume from gamma ray. So this is regarding choosing the indicators. The output here is the clay volume from density log. But here in front of density, we have to define to the software that density is displayed by ZDNC. It only defines neutron, but it cannot define the density as being displayed by ZDNC, since it is since the service company here used another symbol for the density log, so we have to define this new symbol to the software to identify it as being density log. So we can define the density log used, which is ZDNC. And already he has identified the neutron log used as CNCF. Regarding the corrections for poor hole or bad hole indicators, we can use the caliber as a bad hole indicator, and also we can use the bulk density correction or Z correction as a bad hole indicator. Regarding the log of clay volume that will be displayed, we have two basic options. Either to display the minimum clay volume, so the software will calculate the clay volume by using the single clay indicator, and also the clay volume by using the double clay indicator, and then the software will choose the minimum value of both calculations and will display it on the log of clay volume. Another option is to use the average value for clay volume, the average value from both of single clay indicator and double clay indicator. We usually use the minimum clay volume indicator. So we can use the minimum clay volume indicator as being an indicator for clay volume, and then we will load or save parameter sets and then I will select all six and choose formation tops. The software will apply this calculation on each formation individually. So these calculations will be applied on each formation within this well individual. So we will select formation tops for the software to calculate the clay cutoff, the clay cutoff, and the clean cutoff for each formation individual. And then we will select load from database, and yes, and then run, and yes. So you have a new track here in this window of clay volume calculation. We have a track including the gamma ray as a single clay indicator, and the second track neutron and density for estimating as a double clay indicator, and this is the pad hole indicators, and then you can see the comparison between the clay volume estimated from gamma ray as single clay indicator and the clay volume estimated from neutron density as being double clay indicator. Now, to display the minimum value of clay volume, we click on the header of this track, and then I will choose to introduce a new log. So I will select the clay to be displayed. It is from 0 to 1, and let's make it on another color, for example, a green or lime or green, and then apply. Let's make it different from green, since we have the indicator from gamma ray is displayed in green. Let's make it for example, as being uh, green, and then okay. Let's make it another color, since this color is so weak to be displayed. Okay. So you have introduced here the minimum clay volume log, and as you will see, this log will follow the minimum value of both of the clay indicator and the double clay indicator here. It will only follow the minimum value of both of these two blocks. And the curve name will be the display displayed in as decimal or percent. Also on each of the indicators, gamma ray indicator and the Newton density indicator, we have the cutoff lines here. These are the cutoff lines displayed here, and we can change the cutoff line value manually as we see here. We can change this cutoff by moving it here. You can see the effect on the calculation window or the calculation track of the clay when you move one of these cutoff here. So this is the maximum cutoff representing the shell zone. This is the maximum gamma ray or maximum cutoff within the formation, and the minimum cutoff representing the clean or the non-shelly formation or corresponding to minimum gamma ray value. So as you see here, by changing this cutoff, you will change the calculation of the clay. Also in the second zone, you can change the cutoff of the clean and shell value. I will make the cutoff for shell value at the maximum gamma ray, and the clean will be at the minimum gamma ray. Also in this second zone, the shell cutoff will be at the maximum gamma ray, while for the minimum or clean will be at the minimum gamma ray. So we can adjust the cutoff here. Also, we can right click on gamma ray and then on the gamma ray track, and then we can select the gamma ray histogram, to change the cutoff on the histogram. We can change this cutoff on the histogram. You can see the boundaries of the cutoff here. I can move this left cutoff here to the start of the histogram, while this is the right cutoff representing the high gamma value. I can move it to the end of histogram here. So this will change the cutoff used in the calculation of V shade from the gamma ray. The same also we can adjust these parameters, or we can adjust the parameters for estimating V shade calculation on the Newton density as indicator. So on the Newton density calculation window for estimating V shade from Newton density as double indicator, we can right click and select the cost plot, the Newton density cost plot, and adjust the estimation on the cost plot. And then from edit format, we will choose the scale from density from 1.95 to 2.95. We have to be sure about, we have to review about the scales of Newton and density on the cost plot here. And then I will select the overlay lines we have different options. For example, if your raw fluid density or the fluid density is 1 for fresh water, in case of freshwater drilling, or if it is 1.1 to 1.19 for saline mud filter. For example, let's assume that our drilling fluid is fresh, so we can use Schlumberger Dennis Newton correction rho if equal to 1. And then I will select apply and then OK. So our cross plot is displayed here. So this is our cross plot have been displayed here, and we can depending upon our identification of lithology for each zone. If, for example, we have a sandstone zone, we have to change the point of the point of intersection for this cross plot to be identical to sandstone if we are working within sandstone zone. So this is our included data here in the cross plot, and we can change the two lines making the triangle to include all or most of the data. To include all of most of the data we have here. For example, let's make this line here. Here. Just try to make it including most of the data displayed here. So basically, by changing the boundaries of within this cross plot, will change the cutoffs which affect on the calculation of the share. So this is regarding this Newton density indicator. Moving now to the indicators for bed hole. Also, we can adjust the indicators for bed hole by from the caliber and the bulk density correction, delta rho B. We can adjust the cutoff for identifying the hole as being bed hole by moving this cutoff here. So if I move, for example, the cutoff for caliber to this position, we can identify this zone as being bed hole here. And then from calculation, we can choose curve from zone parameters, and then the parameter set will be clay volume. The result curve, the output parameters value, we have the bed hole 1 minimum. The result curve will be, let's make it bed hole from caliber bed hole from caliper. Then okay. Then we can choose for bed hole to minimum. We can define it as bed hole from Z correction. So now we want to build the curves. We want to build the curves from these defined values of cathode. So I will click OK. And from calculation, use a formula. I will select if caliper X is larger than or equal to the bed hole caliber, and or let's make it all Z correction larger to or equal to two hole Z correction, then it will be 1, otherwise it will be 0. And then the result curve will be bed hole. We can call it bed hole. And units for this curve will be in inches. So I will click on one. Then close. Now we want to display this bed hole curve. So we can display it with the track of gamma ray. I will click on the gamma ray track and then introduce a name, the bed hole look, bed hole from 0 to 10. And let's make it as green or dark orange. Then apply. Then okay. So as you have seen, this is the curve for bed hole in inches. We can use also shading. The shading for bed hole. From fixed value view. And the cave name will be bed hole. And the shading type will be, for example, black. And then apply, and OK. So you can see here, we have introduced these signatures indicating the presence of bed hole here.